Okay, Rowan's been attended to. Now he's eating lunch. Okay, so we set up, or we figured out what our B, our A, and our C are, and we could easily put those things into the little formula here, b squared minus 4ac, the discriminant, and basically get this. So my b squared becomes 4k squared. It's negative 2. I got to square both of them. It becomes positive. Negative 4 times 1 times k times a times c. And then I went ahead and factored that out. I notice that is a common factor of 4k. Okay, so rather than go straight to A, I went to B. And you'll see why in just a minute. So on B, this is the one that probably was not that big of a deal to you trying to solve this on your own. So I set it equal to 0. That's what's supposed to give me one real solution. But since I have, this is basically the zero product property. It's factored, it's equal to 0. I set each of those factors equal to 0. So I get k equals 0 and k equals 1. So with these two answers, if I were to substitute either one of those into this equation, it's going to give me one real answer. The reason why the next two are a little tougher is because now we're working with inequalities. So let's go back up here to A for two real solutions. So this time it's going to be 4k times k minus 1, and it's going to be greater than 0. So, well, I could go ahead and divide by 4. Now, solving quadratic inequalities is not the same thing as solving quadratic equations. Instead, we're going to base it on these two answers that we got over here. And these two answers are going to be called the critical values. Let's put CV for critical values. Now, if I put those two things on a number line, here I get my 0 and here I get my 1. Obviously, they cannot be equal to those two numbers because it says it's greater than. So I'm going to put an open circle around this one and an open circle around that one. Now, it's going to be an interval, right? Because it's an inequality. So let's just test some intervals. How about I test the number 2? 2 is going to be pretty easy to test. Let's plug number 2 in here. So here I've got 2 times 2 minus 1 is 1. That's equal to 2. Is 2 greater than 0? It sure is. It checks out, which means everything over here is included. And then this means also something over here is included. If you don't believe me, just go ahead and test out, say, negative 1. So negative 1, if I plug that in here, out here I'm going to get negative 1 times, and then I'll have negative 1 minus 1, which is negative 2 times negative 1 gives me positive 2. Again, it's greater than 0. So my answer here is the interval from negative infinity all the way up to 0, union 0, no, sorry, 1 all the way up to positive infinity. Holy smokes. Now, if you're uncomfortable with quadratic inequalities, don't worry. In the next unit, we'll talk about those things in quite a bit of detail. All right, let's finally move on to the last part of this, part C. Change the color. Let's change it back to red-ish. Change it back to red. Come on. There we go. And let's do the same kind of thing, part C. Now this time, go ahead and go with me that this is just going to be k times k minus 1. Clean that up a little bit. There we go. K minus 1. This time less than 0. I didn't put the 4 there because I'm just going to divide by it. So same exact setup. I get my 0. I get my 1. They're not included because it's just less than. Let's go ahead and test that number 2 out again. Do I really need to test it? Well, if I stuck 2 in up here before, I know that 2 made greater than 0. Here it's going to be 2 is less than 0. That is a false statement, so it's not going to include anything there. It's going to include the stuff that's right here in the middle. Oops, right there in the middle. So this one, the answer is the interval from 0 to 1. Anything in between those are going to give me two imaginary solutions. Now, let's just think back for a second. Notice that this is a less and, that shortcut, and this one is a great 4. And look at those two answers. Wow, that was pretty challenging. Okay, so that about wraps up section 4.8 about quadratic formula using discriminant. So we were able to come up with a quadratic formula using completing the square. And that quadratic formula is x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. And then we're going to use that thing to solve any old quadratic equation. Second one, the discriminant, is the b squared minus 4ac. It's the part that's tucked underneath that square root. Just depending on what value it is, going to determine how many answers, what kind of answers we have. Whether it's greater than 0, I have 2 real ones, equal to 0, 1 real one, or less than 0, 2 imaginaries. Oh, and here's your assignment. Wait, what? What? Oh, hey! What is it?
I like you, Miss Nice. You look like a doctor.